Hello friends, we'll start with the basics of machine dynamics, which is mechanism actually. uh, Let me change the color. uh, if I ask what is mechanism, what is mechanism, then we can say if a number of bodies are assembled in such a way that the motion of one causes constraint and predictive predictable predictable motion to the others, then it is known as a mechanism. I'll be clearing this, means what exactly the statement says. And a mechanism transmits and modifies a motion. Okay. Now, if we are going to understand this statement particularly, then let us take an example. Okay, example is, suppose I will take a reciprocating engine. In the reciprocating engine, let's say we have a crankshaft here, which is connected with a crank. Okay, with the crank, this is the radius that the crank covers, and other end of the crank is connected with a connecting rod. So I draw it here like this. Let's say this is our connecting rod. A connecting rod is connected with a piston, suppose. So we have a piston here, and it is reciprocating inside a cylinder. Okay, so let's say this is our cylinder. I will hatch this cylinder to indicate that it is fixed, only the piston is moving inside, so it is a fixed one. So in total, this is our mechanism, we can say. Okay, this is our mechanism, right? Here we have several parts. Okay, you can say, let me change the color for better view. Let's say this is our piston, this is connecting rod, this part is our piston, this is cylinder. Okay, so here motion of one element, let's say, sorry, this one is our crank. So the motion of the crank, okay, if the crank is rotating about this crankshaft, let's say this is crankshaft, So what happens when power is received? First the crankshaft rotates, and when the crankshaft rotates, the power is transmitted to the crank, so the crank starts rotating. So when the crank rotates, the connecting rod also moves, and the piston attached to it also starts reciprocating inside the cylinder. Okay, so because of one motion of one element in the mechanism, other starts a constant and predictable motion. Okay, and so this is an example of your mechanism, right? Now what is machine? Okay, if I say what is machine? Now machine is basically can write a machine is a mechanism or combination of mechanisms which apart from imparting definite motion to the parts, also transmits and modifies the available mechanical energy into some kind of desired work. Okay. Now another important aspect is the difference between analysis and synthesis. Okay. What is analysis and what is synthesis? Now analysis. Analysis is basically a study. It is basically study of motions and forces concerning different parts of an existing mechanism. Concerning different parts of an existing mechanism. Okay. Now what is synthesis then? Synthesis it involves the design of different parts. Okay. Now study of motion doesn't requires any information. Okay. This study of motion does not require any information about material being used in the component and the associated force. Okay, it is simply a study. Okay. Now for example, as I discussed about that crank and connecting rod mechanism, that reciprocating engine, okay, which we discussed, the same I am repeating here. We have, this is our cylinder, so okay, let's say this is our crank. This I have already told you. This is connecting rod, cylinder, and we have a piston here. Here you can see the piston displacement depends upon the length of the connecting rod. Okay, the displacement of the piston inside this cylinder depends upon the length of this connecting rod. Okay, length of the connecting rod. Now, so we can write piston displacement depends upon the length of connecting rod, right? It doesn't require any information about the bearing strength bearing strength of parts are the forces they could bear or not. Okay, therefore we can say study of mechanism is categorized into two disciplines. What are they? First is kinematics, then second one is dynamics, right? These two categories are there. Now what is kinematics? We say what is kinematics? Kinematics deals with basically, let's say, kinematics deals with the relative motion of different parts, of mechanism without considering the the forces involved in it. Okay, it is the study to know about the displacement, velocity, and accelerations of a part of a mechanism. Okay. Now what is dynamics? Dynamics involves the forces impressed on different parts of a mechanism, okay. The applied forces may be static or dynamic Now dynamics is further divided into two categories, subcategories. Dynamics is further divided into one is static, okay, another is kinetics. Now what are they? When you say about static, okay, it deals with forces basically. It deals with forces when the body is at rest, okay. And what is kinetics? Kinetics is the study of forces when the body is in motion. Now if I am telling about motions, what are the different types of constant motions? Okay, we will see types of constant motion. Now there are basically three types, okay. First is completely constrained motion. Second is incompletely constrained motion. Third is successfully constrained motion. Now what is the difference between these three? We'll discuss with the example. So first, let's say completely constrained motion. What is that? We take an example. Let's say we have a block like this, and with a through hole in it. Okay, there is a hole like this. You can draw simultaneously with me, so that you will have a good note, because I will be completing the whole syllabus of this dynamics, and it will be very useful to you. Now let's say this is like this. On the other side we have so we have this rectangular element inside a block, we can say, which can only have a to and fro motion inside. Okay, so this is basically example of a sliding pair. You can say what is pair we will discuss later, the later part of our syllabus. Another example, if I take, let's say we have a hollow cylinder and we are looking from the front, so it will look like a rectangle basically. Okay, this is the center line, and on both ends colors are attached to it, right? And we have a shaft. You have a shaft like this, okay, and the inside portion is indicated through this dotted line. So this is basically a turning pair, turning, turning pair. Okay, so let me indicate the parts in both the cases. This is a hollow block, you can say. This is a rectangular shaft. This is a cylinder, hollow cylinder basically, and this is a shaft. This one is collar here. So these two pairs, that is your sliding pair and turning pair, are example of this completely constrained motion. Now what is that? When motion between two elements of a pair is in a definite direction, irrespective of the direction of the force applied, it is known as completely constrained motion. Okay. So examples of this kind of motion, as you have discussed, one is your sliding pair, another is your turning pair, right? Then next is your incompletely constrained motion. Incompletely constrained motion. What is this? Now, when you can say when the motion between two elements of a pair is possible in more than one direction and it depends upon the direction of force applied. It is known as incompletely constrained motion. Now, if you draw a schematic of an example, let's the same turning pair that we discussed earlier. We have this hollow cylinder here, but this time without any collar. Okay. Let's say hollow cylinder. This is the center line with the shaft inside. Okay, the shaft inside. So the shaft is rotating, and because of the absence of any collar, it can also translate. Okay. So we have two motions here, one rotational motion, another is the translational motion. So this is example of a incompletely constrained motion, right? This is the cylinder and this one is the shaft. Okay. Now third one, a motion category of motion is successfully constrained motion. Successfully constrained motion. What is this? Now when can say when the motion between two elements of a pair is possible in more than one direction, but it is made to have motion only in one direction, by using any external mean. It is called successfully constrained motion. Example, let's say we discuss the example of successfully constrained motion. We can say shaft in a footstep bearing, then piston in a cylinder. For example, let's say we have a bearing here, one footstep bearing, we can hatch this to indicate the cross-sectional view, and the shaft is connected in this fashion. This is the center line of the shaft. So this is the shaft, you can say. And we have certain load acting on it. Okay. This is the load acting on the shaft. So this is our shaft, and we have the bearing here. Okay. So this is example of successfully constrained motion. In spite of this load acting on it, okay, we are able to rotate this shaft inside. Okay, though it may come out, but it is not coming out because of this applied load. So this motion is prohibited here. it is only rotating inside. Okay, so this is a footstep bearing. Okay, example of successfully constrained motion. So today we will discuss up to this, and we will proceed further, and we will discuss further about rigid bodies, resistant bodies, what are the types of links in our further classes. Okay, thank you.